concluded that so all periodic motions are not oscillatory, but all oscillatory motions are in periodic nature. So periodic means we get to know the motion which repeat itself after a regular interval of time. So oscillatory motion, it will make it to and frozen. So that's why I say that so the all periodic motions are need not to be oscillatory. All periodic motions are not oscillatory, but all oscillatory motions are in periodic nature. So mainly to cause the oscillations, there is a two properties required. Causes of oscillation in a system, mainly it is due to the two properties, that is inertia and elasticity. So the oscillations will take place, mainly it is depend upon the physical system of, that is inertia and elasticity. Inertia and elasticity. Elasticity. So inertia, what every body continues in a state of rest until we are applying the external force on it. So if we consider if we take any body, so that body will be at rest. The spring will be at rest until we are applying the external force on it. So when we used to apply the force, then it starts to move. So that is nothing but what is inertia we used to use. And elasticity, the property of a body which is having a tendency to regain its original shape and size of a body. So that is dimension of the body, which is having a tendency to regain its dimension of a body after removing the external force. So that what elasticity says, that the property which is having a tendency, having a tendency to regain its original, regain its dimension after removing the external force. So which is having a tendency to regain its dimension after removing the external force. So that is, suppose now we will consider a spring which is attached with the mass. So spring which is attached with the mass. So when we used to apply the force on it, then what will happen when we used to apply the force? Then there is a changes in its dimension, whether it may be expand or it may be compress about the main position. So what will happen? It will expand. So this is in the form of elongation. When we used to compression form. So that from the mean position here the displacement is elongated, and here the body will be compressed, so through a displacement x. So mainly here the force which is acting, that is restoring force. F is equal to minus kx. So that negative sign which indicates that the restoring force which is acting opposite to the motion of the body. So that negative sign. So that's that elongation and due to compression. So that negative sign. And where k is the proportionality constant and x is the displacement. So, and the acceleration. What will happen? Acceleration here. So in this, when the body is oscillating, so if we place a body about the center to the fixed point, so initially the displacement will be 0. So initially the displacement will be 0, and at this point initially the velocity will be maximum. Velocity will be maximum and the acceleration is also 0. But when the body will displace from the initial point, so then what will happen when the body is shifted from the mean point, when the body is shifting from the mean point, so then the displacement so here the acceleration is always directed towards the mean position, whether it is in negative direction or positive displacement, but the acceleration is always directed towards the mean position, but opposite to the displacement. Suppose here the displacement will be in positive, then the acceleration will be negative. The displacement is negative, then the acceleration will be positive, the opposite. And the extreme point, at the extreme point the velocity will be minimum. At center the velocity will be maximum. At the extreme point the velocity will be minimum or 0 at this extreme point. Velocity will be minimum or 0 at this extreme point. So totally it is depending upon the main properties of the elasticity and inertia. So based on the oscillation will takes place about from the mean position. So when a particle initially at the state of rest, so at the time the velocity will be maximum and the displacement will be 0, and after moving some interval of time, extreme point, then when it is at extreme point the velocity will be minimum, and when it will turning takes place it will make a to and fro oscillations. So that is in the positive direction or in maybe in the negative direction, but acceleration is always directed towards the mean position. So that force is directly proportional to the negative of the displacement. Means the restoring force which is acting on a body, that is in the opposite direction, opposite to the displacement, and acceleration is also directly proportional to the displacement. Acceleration is also directly proportional to the displacement, but that is in the opposite direction, whether it may be in suppose the displacement will be positive, then the acceleration will be negative, vice versa. So this is the causes of the oscillations we used to observe. And the SHM is mainly next we are going to study the mechanical oscillations. So that is very important, that is simple harmonic motion. So the next concept is simple harmonic motion. Yeah, the heading itself indicates that this is a simple, very simple to and fro motion will takes place. So it is a very special type of oscillation. It is a special type of oscillation So it is a special type of oscillation in which the acceleration always directed towards the mean position. Always directed towards the mean position. Directed towards the mean position. So it is a very special type of oscillation in which the acceleration is always directed towards the mean position and its magnitude is directly proportional to the displacement about a fixed point. About a fixed point. So that fixed point is so what will happen when we used to consider a body, so that is make a to and fro oscillation, that will make a to and fro oscillation, but in this acceleration is always directed towards the mean position. Whatever the displacement will happen, so but the acceleration is always directed towards the mean position and its magnitude is directly proportional to the displacement. So what are the magnitude we used to consider? That is directly proportional to the displacement. So what is the extreme position that is to displacement, positive or negative? So and this is about the fixed point. So what fixed points at this point, or it is called as a fixed point, is called as a center of oscillation. Center of oscillation. So it's a fixed point is called as center of oscillation. So it's always directed towards the and the magnitude is directly proportional to the displacement. So that means if we consider, so it is mainly the simple harmonic motion, any motion that is works on the Hooke's law. So that if we consider force is directly proportional to the displacement, so that is in opposite direction, and its magnitude, so that magnitude is also directly proportional to the displacement. If we consider take any magnitude, that is directly proportional to the displacement. Then what are the characteristics of simple harmonic motion? Characteristics of simple harmonic motion. So simple harmonic motion So then what are the characteristics of this simple harmonic motion? So one is it is in periodic motion. That means after some regular interval of time, the motion which will repeat itself. Yeah. Also this is in periodic motion, means which will repeat itself, and also it will execute say to and fro motion. So it is in periodic nature also, and it is oscillatory also. Okay. So it is in periodic motion, and the acceleration is always directed towards the mean position. Is always directed towards the mean position. Acceleration is always directed towards the mean position. So, and the restoring force which is acting on a body, so that is in opposite direction. Is in opposite direction. So what is the force that is which is acting, that is in opposite direction? So that's why this negative sign indicates that the force which is acting on a body is in opposite direction. So that will indicate this negative direction. And the body will displace it, when displaced from a mean position, when displaced from mean position, the restoring force is trying to bring the body back to its mean position. When a body will move towards the extreme point, then that restoring force which is acting on a body, it will try to bring that body to its mean position, initial position. That force, the restoring force which is trying to bring that body back to its mean position. So these are the characteristics of the simple harmonic motion. So one, it must be in periodic. It must repeat itself after regular interval of time, and the restoring force which is acting on a body is in opposite direction, that is opposite to the displacement, for this displacement. So that's why force is done. And when displacement from mean position, the restoring force is trying to bring the body back to its mean position. So these are the characteristics and the definition of the simple harmonic motion. So based on that, next we are going to find out the differential equation for the simple harmonic motion. So then what are the differential equation and what is the solution for that a simple harmonic motion? So that we have to find out.